Hello everyone, welcome to my weather forecasting tutorial. Today our forecasting model will be focused on LSTM, and before we jump into the data encoding section, it is often a good practice for us to understanding some of the domain knowledge. And I did actually found a quite interesting website that have explained further on the metrics that used to describe our weather. So in this website, you can see that they're actually describing the weather in four metrics, which are the air pressure, temperature, wind, and also the humidity. You all can go through the details with the link that I attached below. In short, we are going to use the four metrics listed here for us to make a weather forecasting model. So let's get started. We will start from downloading the data for the Kaggle website. So I will download the data from this link, and I will also attach the link in below, so you all can actually download the same data and did the tutorial as the way I showing. Instead, I actually found that the pandas have some difficulty to handle the data format in this kind of microsecond that listed as a extra information. So first of all, after I download the data, I will process the data in the Excel first for the date time. So after I process the data in the Excel, then we can just open our Jupyter Lab and load the data into our Jupyter Lab, which is the weather history.csv in our case. So first of all, we will try to import all the necessary library for use to make the weather forecasting model. Indeed, a good practice to involve in the ML experiment. First thing that we should actually do is try to set the seed, then actually try to make some randomized variables such as in the rate initialization to stable, to be constant. So first of all, we will declare all the functions that needed in here. So the first function that I doing is for the speed sequence, and what is about the speed sequence I will explain further in the section below. So first of all, we have our data ready in the Jupyter Lab. Then we will load with CSV, and what we try to do in the first, we will try to set the date column to be our data index. So we also have to try to make the index to become a date type format. Indeed, we can now try to check our column consists of what kind of data. So as discussed in the beginning, we will using four parameters that listed in the website, which is the temperature, humidity, pressure, and also the wind speed. So to shorten down my training time, also my laptop has some spec limitation. So I would like to upsample my data into daily format. So this may shorten down the data into 4018 rows. And let's check again for our columns. So in here, oops, I actually forgot to run my code, and let's restart again. So quickly go through the function that I explained just now. And after we check our columns, there are actually good practice for us to do a normalization towards the data. This is for us to prevent the exploding gradients. Also, another thing that we should always check is either there is a null value in our data. So after we check the null value data, this can help to prevent us that the loss function will not be none. And the next one we will come to the split sequence. So what is a split sequence is about? Actually, it's a common data format that we have to remove for the time series forecasting. So first thing that we should do is actually we are trying to do here is actually we are using 120 days before to forecast a day after. So in our case, the 120 data will start from the x, then x plus 1, x plus 2 until x plus 119, sorry. So this all data will use to predict the x plus 120. So for the next data that will fit into our model is actually plus 1 for the input and also plus 1 for the output. So in here you can see that I declare the n step up to make it link to this situation that I described just now. So the split sequence actually will also in my function is also actually helps to make a trend and test split. So in here we will declare three variables, which is the n neuron and also the approach and also the n feature that we will use. So our case, our n feature will be 3 is 4, sorry, which is I explained just now, which is the temperature, humidity, and pressure, and also the wind speed. So here we check again for our data shape. So to make it to able to accept by the LSTM model, actually we have to arrange in a data size, which is data sample in the first column. Then the second one will be the n step in. Then the last one will be our features. So instead, you can see that we are actually using a 47 test set to validate either our training is successfully. So for the training data, we can actually run this function now. And sorry again, this I forgot to run my function again, and I will run now. So for the training parts, actually I have done the training just now. You all can try to run the training parts, then it will consume some time for the order to computing the result. So after you all done the training, you all can actually save the model with this syntax. Then when the next time you want to use the model, you can just do it with this syntax. So it will also wait for a few seconds for the model to load. So after that, then we will try to in here we will try to inverse transform for our test set that is already go through the min-max scalar just now. So after we inverse transform, then we actually can check back with the data that we load at the beginning, which is the DF fundamental. Then we check for the last 47 rows, as our test data is 47, as listed in the print size just now, the data shape. So we can refer back this is for the first column of the data. Then we can check the last one is 0.07. Then here also is 0.07. Then you can check further for the 1, 2, 3, 4, 5, 6, the last 6, then 2, 4, 6 will be 0.340741. So it's actually same. So you can say the data is successfully inverse transformed. So in here we are trying to do is we are trying to throw the test data in, then the model will actually predict the test data. So the test data we also have to reshape into the data shape that can accept by the LSTM as what we did in the training just now. So after we get the predicted output from the model, then we also need to do an inverse transform. So after that, we will append our data into the list which is in the y predict. So in this next function, what we are trying to do is actually, oops, I forgot to run my function again. So give me a minute. So in here, we are trying to look different of the data in the y predict to separate list. And with this, we can have a better go through with calculating the arrow and also for the graph plotting. So for the next one, actually make a function to calculate the error rate for the forecasting model. We will be using three metrics to validate our error, our training error, which is the mean absolute error. Then another is the RMSE. Then the third one will be the MAP. So after we compute the error rate, then I will put into the result and make a swapping. So at here, you can actually see that the pressure is actually at the highest MAE and also the MASE. IMSE, sorry. So from here, we're still not able to judge which of the variable that is actually performed worst, as the IMSE is quite related to the data point range in our dataset. So we can actually further compare with the mean. So we can see that the pressure actually have a quite high data point range when compared to the temperature, humidity, and the wind speed. So when compared to the mean value for each data, then we actually can see that the pressure is actually not that bad when comparing with other variables. Yeah. So we will further look into our result in the graph mode. So the first one will be the temperature. So you can see that actually the temperature is predicting quite well. It actually follows the trend, but then the base level is a bit different. So the next one will be the humidity. Humidity also actually done a quite similar thing with the real one, the real result. Then also you can say that it actually performed not bad. Then the third one will be the pressure. And so here you can see that actually the pressure is not quite satisfying the result, but we can try to make some improvement later. So for the humidity, actually we can see that the performance of the model is not really quite satisfying for our outcome. So one thing that we can do is try to tune the model. So in here, I would like to use a tangent h instead of the value. So sorry, I forgot to explain just now. Actually, the lattice.hy is using a value estimation layer, and now I will load the width that is trained with the tangent h. Then we can see that what's the difference. So we run again for our function after the test. So we run everything. So in here we are actually see that the pressure, RMSE and MAE has decreased quite a lot. And also we run everything again. Then you can try to plot the graph and see again. And we see the temperature not much different from just now. And this graph from just now, then we can again see, which is also not much different. And again for the pressure, okay, now we can see that actually the pressure is quite following the trend. So we can also judge that it's actually also predicted quite well. The pattern also is quite similar. So for the last one, for the humidity, and it is improved quite a lot, especially for this part as compared with just now, and it's quite surprising result also. Yeah, so for you that want to try to improve further for the result, you can try play more with the parameter that is in the model, try to do more the parameter tuning, and also maybe you can remove more of the feature instead of just 4 that listed in this tutorial. So that's all for me, and thank you guys for watching the video, and see you guys next time. Yeah, thanks.